In this textbook, we will be discussing three major types of bonds that occur between atoms. The first one is called an ionic bond, and a purely ionic bond comes about from the attraction of a cation and an anion. So the species involved with the bond, one of them is positively charged, one of them is negatively charged, and positive and negative charges like to interact with each other. Inside of this interaction, when we form the ionic bond, there will be a complete transfer of electrons from one species to another. So ionic bonds form when one reactant loses an electron readily. So by this we mean a low ionization energy. It readily gives up an electron. So if we look at our periodic trends, that would be a metal on our periodic table. So as we go left and down the periodic table, the ionization energy becomes lower. So the species tend to give up electrons. The other reactant needs to be able to gain an electron readily, and so that's an electron affinity. So remember, electron affinities increase as we go up and to the right on the periodic table, so that tends to be a nonmetal. And if you remember when we discussed how to identify an ionic bond, we would always say it's a metal bonded to a nonmetal. And now we understand why that's true, because metals readily give up electrons, nonmetals readily gain electrons. Another way of looking at it is by viewing the electronegativities of the bonded atoms. And when the electronegativities are very different, you tend to have an ionic bond. So a large separation on the periodic table tends to create ionic bonds. So the metals are on the left-hand side of the periodic table, nonmetals are on the right. There's a very large difference between the electronegativities of the bonded atoms, and so the electrons are completely pulled away from one atom and onto the other atom. Why an ionic bond forms is because the species become more stable and gain a noble gas configuration. So if you were to look at the electron configuration of sodium and the electron configuration of chlorine, they both have a noble gas configuration. So by losing an electron, sodium plus gains the electron configuration of neon, and by gaining electron, Cl minus gains the electron affinity of argon. And so we had seen this when we were talking about the electron configuration of anions and cations, that most of the time elements tend to gain or lose electrons to get to this noble gas configuration. So by forming ionic bonds, the elements involved in the ionic bond most of the time gain noble gas configurations and gain a certain measure of stability. The next type of bond is called a covalent bond, and here electrons are being shared. So there's literally an interaction between the two atoms involved in the bond where the electrons are being shared between the two atoms. A couple of good examples is like H2 and Cl2. We get a covalent bond when the electronegativities of the bonded atoms are very similar. So the pull on the electrons involved in the bond are kind of equaled out, so it doesn't favor one atom or the other. So when we look at the atoms involved in the bond, they are neutral compared to each other. So the electronegativities are so small that the electrons involved in the bond are not pulled closer to one atom or the other, so they're relatively neutral to each other. And this only occurs when the electronegativities are very similar, and most of the time when the electronegativities are exactly the same. So like in Cl2, you have electrons between two chlorines. The chlorines have exactly the same electronegativity, and so there's no shifting of the electrons inside of there. We're going to find that very few bonds are truly purely covalent. Most bonds that we see are the third type, which is called polar covalent bonds. And this is when electrons are shared, but they're not shared equally between the two atoms involved in the bond. So what happens is the more electronegative element tends to pull the electrons slightly closer to itself, and in doing that it causes a separation of charge inside of the bond. So here, if we have a polar covalent bond between A and B, and I say that A is more electronegative than B, the electrons inside of this bond are pulled very slightly closer to A, and it gains a partial negative charge. So this delta here means a partial negative charge. With B, the electrons are being pulled away from it, and so it gains a partial positive charge, and this is why we call it a polar covalent bond. The electrons are still being shared, but not equally. One atom has more of the electrons, one has less. To be able to formally tell which one of these three types of bonds is going on between the atoms, ionic, polar covalent, or covalent, what you can do is look at the difference in electronegativity between the atoms forming the bond. So these are just constants that you can look up. They typically have periodic tables where they show the electronegativity of the elements. And if the difference in the electronegativity between the two atoms involved in the bond is very large, so in this case greater than or equal to 2, the bond is ionic. So large differences in electronegativity tend to create ionic bonds. If the difference in electronegativity is very small, you tend to have a covalent bond. So if the electronegativities are very close to each other, you tend to not have that separation of charge, and so you create a covalent bond. And in between these two, what you make is a polar covalent bond. If I ever need to know what type of bond we are looking at, you need to look up the electronegativity of the two atoms that are involved in the bond and look at the difference of electronegativity between the two.